Architecting scalable permission systems, from basic roles to attribute-based defense in depth. If your product hides a delete button in the UI and calls that security, this video is for you. We will walk a practical path. Authentication versus authorization, why scattered checks fail, how to centralize decisions when RBAC is enough, when ABAC is required, field-level filters, database scoping, and defense in depth. This is architecture for defenders, how systems harden, not how attackers bypass. Think of permissions as product infrastructure. Every SaaS eventually rediscovers this the hard way, usually after a support ticket that should have been impossible. Never assume login equals full access. Authentication answers who are you, confirming the doctor is logged in. Authorization answers what are you allowed to do, deciding whether that specific doctor can open that specific restricted record. A valid session is not a master key. Treat every sensitive action as a separate decision after identity is proven. In healthcare, finance, and multi-tenant SaaS, confusing these two words creates real incidents. Keep the vocabulary precise in design docs and code reviews. Scattered permission checks are fragile. If rules live in page guards, button logic, and random API middleware, the system is fundamentally insecure. Attackers and honest bugs both go straight to the API. UI checks are convenience, not enforcement. When permission logic is spaghetti across the front end, the database path becomes a highway with missing toll booths. Ask your team today, if someone calls the delete API with a valid cookie, does the service layer still deny? If the answer is we hide the button, you have a security gap. The fix starts with architecture, not more of statements. Centralize security logic in a dedicated service layer, so one permission rule controls the whole application. UI, API, and mobile all funnel through create, read, update, and delete services. Direct database paths are forbidden. Consistency beats clever one-off checks in every route handler. Put create document service, read document service, update document service, and delete document service behind the same gate. Clients never touch persistence with private rules. Role-based access control is the perfect starting point when permissions map cleanly to job titles. Admin manages everything. Editor updates documents. Author edits their own work. Viewer is read-only. RBAC is easy to explain and easy to audit. Ship it first when your product is still role-shaped. Document the role matrix in one table, owned by product and security together. Ambiguous role names are how privilege creeps in through onboarding tickets. RBAC breaks when rules depend on ownership department, document status, or lock state. An author role is not enough if the draft belongs to someone else. An editor role is not enough if the document is locked. Roles alone cannot express those conditions without exploding into dozens of micro-roles nobody can maintain. Role explosion looks like editor East Coast draft, only locked docs. That is a symptom you need attributes, not more role strings. Attribute-based access control injects context. Evaluate user attributes, resource attributes the action, and the environment together. Example, user is owner, and document is not locked, and document is draft, and user is in the same department. Only then grant edit. ABAC is how you keep policies expressive without inventing a new role for every edge case. Keep attributes typed and explicit. Department ownership, lock state, and environment should be data, not comments in a middleware file. Diagnostic comparison. RBAC is driven by who the user is. ABAC is driven by context and characteristics. RBAC is static and easy to audit, but it breaks down through role explosion. ABAC is dynamic and highly aware, more complex to build, and scales with rules instead of role names. Choose RBAC for clarity. Add ABAC when context starts winning arguments in design reviews. A useful heuristic: if a rule needs the word unless, you are probably past pure RBAC. Encode the unless as attributes and conditions. The universal enforcer is a single point of truth. Every permission check, UI button, API endpoint, server backend, must call one trusted function such as can user action resource. Example, can cacheif update this document? One decision function means one place to fix bugs, one place to audit, and one place to add new policies. Naming the function can is intentional. It reads like a question and forces a Boolean decision. Avoid half-open helpers that return maybe. Encode can evaluate subject action resource and request context through your policy engine. The UI uses it to show or hide controls. The API uses it to return forbidden. The backend uses it before writes. Same signature everywhere. If a layer invents its own private permission logic, you are back to scattered insecurity. Throw forbidden error on deny at the API. Hide or disable controls in the UI, using the same can result. Never invent a second truth for the front end. Surgical precision at the field level. A viewer may read the document without seeing every field. Filter the payload before it leaves the server. Title and content may be allowed. Internal notes and salary may be redacted. Resource access is not field access. Least privilege applies inside the object, not only at the object boundary. Serializers and GraphQL resolvers are common leak points. Apply field policy where responses are built, not only where routes are declared. Defend against malicious payloads on write. Never trust form data. Field-level write protection must silently discard unauthorized modifications before saving. A client may try to set is locked false or role admin in the same post as a title change. Those fields must never reach the database unless the policy explicitly allows them. Mass assignment shows up in ORMs that eagerly map request bodies to models. Disable that pattern. Bind fields deliberately. Whitelist the writable fields. Pick title, update the database, drop everything else. Mass assignment bugs are privilege escalation bugs wearing a friendly JSON coat. Fail closed, unknown fields do not get written by accident. Log discarded sensitive writes in security telemetry when useful, without logging the forbidden values themselves in plain text. Push permissions down to the database. The wrong way extracts 100% of the data into server memory, then filters, creating memory bottlenecks, high overhead, and leak risk. The right way injects permission logic into the SQL or ORM query, so only allowed records are transferred. Authorization must protect the data layer natively for both security and performance. Multi-tenant leaks often start as load all then filter. Fix the query. Then add tests that prove cross-tenant rows never appear. Do not find many, then filter in RAM. Scope the query with tenant, department, and readable scopes up front. Pre-filtered results are faster and safer. If forbidden rows never leave the database, they cannot leak from a careless serializer. Pair query scoping with indexes on tenant and ownership columns, so secure queries stay fast as data grows. When your manual permission matrix becomes a liability, consider a tooling library such as CASL. It reduces boilerplate, supports conditions, and handles field-level rules. Trade-offs exist: React server component friction, less type safety than a bespoke TypeScript engine, and a team learning curve. Adopt a library when maintenance cost exceeds learning cost, not as cargo cult. Whether you choose CASL or a custom engine, the architecture principles stay the same. One decision API, conditions, field rules, and fail-close defaults. The master blueprint is defense in depth. Authentication proves identity. The UI hides what users cannot use. The service layer enforces can before actions. Field filters redact sensitive attributes. Database filters scope queries so tenants and departments never cross. In a modern SaaS app, users only see their company's projects, their department's documents, and the editable fields their role allows, because every layer agrees. Defense in depth means a UI bug cannot become a data breach by itself. Each layer assumes the layer above might be wrong. Secure by default. A strong permission system is not about hiding buttons in the UI. It is about protecting data at every layer of the stack. The best architecture is centralized, consistent, type-safe, and fail-closed. Build the vault once. Make every request walk through it. Fail-closed means uncertain equals deny. Type-safe policies catch mistakes at compile time. Centralized means one audit story. That is scalable permission architecture. Separate Authn from authz, centralized decisions, start with RBAC, graduate to ABAC, enforce with one can function, filter fields on read and write, and scope the database. Comment PERMS for the checklist, and subscribe to Life of Geeks for more engineering architecture deep dives. Make the next feature fail closed by default. Comment PERMS if you want the checklist. Subscribe for more architecture deep dives from Life of Geeks. Build the next feature so the unsafe path is the hard path.